Welcome to this new video. We will explain in this video a new concept of functions. So this is chapter 3 of the book, Functions. And these are the objectives of this chapter. So we will construct programs using functions. We will use the common math functions available in the C++ standard library. We will see the mechanism of passing information between functions and returning the results to the main function that called the other functions, as well as many other things we'll see during covering the chapter. Basically, the main idea of function is we write a piece of code and then keep reusing it again and again and again. So it's a way of having saving our time and using the same piece of code many times. You can always click on the lesson as we have here and start reading the lesson and then answer the question so you can progress into this lesson. Now, in the meanwhile, we will have some experiments with ready-made functions. So these are libraries, and we've been using some functions. For example, in the cbot, move is a function, turn is a function. And as we have said before at the beginning, that main is a function, and we can distinguish functions between functions and variables by the parentheses that follows the function name. So these are the parentheses. And we have, for example, here two arguments for this main function, and we can have functions with no argument, as we have like this. And functions usually have a return value, such as here it's returning integer. This main is returning an integer. If a function returns nothing, then instead of int we just write void. So it will be void, means it returns nothing. Hence, if I'm gonna put a void, I should not have a return statement at the end of the function. But let me have it back into its main as an int. Now, as an example of a simple implementation of a function, we can have, say, if I have a piece of code to print number of stars on the screen, such as if, for example, if I have int, say, x, and then ask the user to enter x, this will be cin x, and then based on that x, I'm gonna have a loop int I equals 0, I less than x, and then I plus plus. Every time I will see out a star on the screen. Now, this piece of code will print star x number of times on the screen, and then I will see out ndl to have a new line. Now, if I execute this program after compiling and having all the, now if I say like 5 stars, it will give me 5 stars. If I execute again and say like 3, then I have 3 stars. Fine. Now, if I would like to have this piece of code in a function, then I'm gonna control X and call it, for example, repeat, then I'm gonna send a star, repeat it like X times. So I'm gonna repeat the first argument this number of times. Now, to write a function that will do this thing here, I just have to generate it, since if I execute it's not defined. So repeat, as we see here, undeclared, it is an undeclared function. Hence, if I say, for example, I have to declare it. Now, is there any return value? No, there is no return value. Return value is if repeat is having a value that I'm gonna capture. Say, if I say, for example, y equals repeat something like this, then repeat is returning a value that I will capture it into y. But in this case, I don't have this this value, so it's a void. We'll explain this part later, but keep it as void. Then repeat. Now, I am now in a process of declaring the function. Now, if I am to declare the function, the first part here is the name of the function. Then between the parentheses, I put the argument, and then I open and close the curly brackets. And this is the definition of a function. Any function has to have a return value, name of the function, then 2 parentheses with any argument, if any, we put it here, and then open and close the curly bracket. This will end up the definition of to declare a function. So exactly as we have here in the main, we have the value of a return value, then we have the parentheses, and then open and close brackets. Now, what determines what number of arguments is how I'm gonna use it. So repeat, I'm using only 2 arguments here. I'm passing 2 arguments. Hence, I need to have here, the first argument is a character, so I have to have this as a character, not a string. So this is a character. Notice a character have a single quote, but a string is double quote, so I just change it into a character. So here I have to have a character, then say character C, you can name it with any name, and then I have an int, this is an integer, x here is an integer, then an int I have like say, for example, n. So n will be substituted with the value of x every time we call repeat. This do not have to exactly be the same name of x. We can have any name here, but I just named it n for simplicity. Now here I will paste the code that I'm intended to repeatedly use it on and on. So I'm Control V. This is the code that I've just cut from here. It was here. I just paste it right exactly in this location. Now, calling repeat will pass this character here instead of C. And oh, but there is one 2 little adjustments I have to do. Now we no longer need to have it loop up to x. Instead, it has to be n, because this is n. Now n, we should fix this one here. It shouldn't loop up to x, since x is no longer representing anything here inside this function. All we know is the c and the n. Now all we know inside this body here is whatever is either defined inside this block or has been passed through the parentheses of the function. Hence, all we know is c and n. It does not know anything about the variables that are declared in the main. So x is no longer x. This is n, and actually this will work here to have it a star, but it will be fixed. So there is no use of having a function unless we would like to reuse it again and again, and putting the flexibility of using it. I should write, for example, c. So c is the variable that will hold the star if I pass it. So star will be substituted into the character c, and c will hold that star, and then it will be printed here. Now, having said all that, if I execute this program, I will get exactly the same output. Say, for example, 5. I have 5 stars. If I say, for example, 3, let's have it here, 3, I have 3 stars. Fine. So what did I benefit of having all the trouble writing it outside and changing the values and passing parameters? And is it worth all the headache? Actually, you will not feel it unless you use it. So if, for example, I call here repeat again, and then have, this time I will have a pound sign, and I'll have it say 3 times a pound, then repeat, then I have this at sign, I'll have it 4 times, and then repeat. This has to be a, and then back to this thing 5 times, and every time I have like C out and L, C out and L, and C out and L. Now executing this thing here. Now this is the first part that I have. I'm gonna enter x, then I'll print the star x number of times. So if I say, for example, x is 2, then I'll have 2 stars, 3 pound, 4 at percent, and 5 hash or pound again. Now, so this is how I benefit of reusing the same piece of code, and every time I just pass the needed or the requested character, and then I just give it instructions of how many times I'm gonna use it. This is one example of using functions and the benefit of reusing the same code again and again, and using this thing here, I can simplify my code, so that if, for example, I would like to have say a square 40 by 40, remember that the homework we had last chapter, then I can say, for example, for int I equals 0, I less than or equals, no, it should be less than 40 because I started from 0. Then I plus plus every time. It will be as simple as that. This is only two instructions. The first one is I'm gonna repeat a star 40 times, and then cout and L. That's it. And I'm gonna repeat this thing here 40 times, and every time I'm printing a star 40 times, so it will be a square 40 by 40. But since the screen have like actually it's waiting for something here. It's waiting for X that will never be used inside this code. So I should have removed that piece of code. So if I just skip this one, so this is a 40 by 40 square. I no longer need all this. So see, this is how I can use the function embedded in a for loop to do many things here. For example, if I would like to have like a triangle, then I'm gonna repeat it every time. The first time will be like 0 star, then 1 star, 2 stars, all the way. Let's see what this will give me. It will give me a triangle like this. So this is a triangle. The first line is 0 star, there is no star, and then all the way to 40 stars, sorry, 39 stars. And see, this is how we can benefit of using functions to repeatedly repeat a piece of code on and on. And this is one example of a function that will return nothing, and we'll see how we can have functions that will return a value. Let me clean up everything here and have it. Okay, now this is a new program. There are ready-made functions for us to use, as in the cbot there are ready-made functions like move, turn, and so on. We have here include the cmath. This is a cmath library. These are some of the functions that we have in the cmath. So if you look up here, we have like ceil. It's a ceiling, so it will round x to the smallest integer not less than x. So if I say, for example, ceil 9.2, so the ceiling of this number here is 10. If I say ceil minus 9.8, the ceiling of this is minus 9, because minus 9 is greater than minus 8. Hence, minus 9 is greater than minus 10. Since minus 9 is greater than minus 10, so we round it to the smallest integer not less than x. And cos is cosine of x in radius, so cosine 0 is 1. exp is the exponential function e to the x, so exp 1.0 is nothing but 2.71, etc. F absolute, this is FABS, this is the absolute value of x, having x as a floating point, because we have ABS alone for an integer absolute. So this is FABS. It takes floating points. So 5.1, the absolute value is 5.1, but when we come to minus 8.76, the absolute of that number is 8.76. So we just remove the sign here. Floor is we round x to the largest integer not greater than x. So 9.2, the floor of that thing is 9. and minus 9.8, the floor of that one is minus 10. F mod is nothing but the remainder, but it will work on a floating point number because as we have seen in chapter 1 that the mod will only work on integers, but here the F mod will also work on floating point numbers. So 2.6 F mod of that number by 1.2 is nothing but 0.2. Log is the natural logarithm of x to the base of e. So this is the application of that thing here. Log 10 is the logarithmic same thing, but this is for the base of 10. POW x comma y. This function here takes two arguments, same as the f mod. It raises x to the power of y, so it's nothing but x to the power y. So if I say POW 2 comma 7, this is 2 to the power 7, this is 128. And POW 9 comma 0.5, this is 3 because to the power of half is nothing but the square root. Sine is the sine function, sqrt is the square root function, and tan is the tan function. So these are some example of math functions. All of them are located in the CMath, and we will have say for example, let us experiment with some of these functions. Now say int, okay, let's have it float x, then cn x. Now, and I would like to have a y also. We can put them both in the same line here, so I'm gonna enter an x and y, and then see out, the output will say POW x to the comma y. So x will be raised to the power of y, and let me write down here x equals x and y equals y, and then I'm gonna say x to the power of y equals, and then just do it like this. Now if I execute, now here I have like 2 to the power 3. Now x equals 2, y equals 3, and x to the power y is 8. Now I'm gonna repeat, let me put and L here, let me repeat, okay, execute again. Fine. Now if I have like 9 space then 0.5, as since I have these two fellows here on the same line, Cn, I can just put a space as I have here, space, and then enter the second number, or I can put them in two separate lines as I've done previously. So I can either type 9 then enter, then 0.5 then enter, or just have them 9 space 0.5 then enter. Now x is 9, y is 0.5, and x to the power of y is 3, because to the power of half. Let me have here a leading space so it looks nice. So this is using, see how I've used this one, POW. This is a function with two arguments. It has a return value. I grab that return value and directly print it on the screen. I can do it as such, or I just cut this thing and say, for example, R as a result, and say R equals this thing here, and R should be like this. So this is what I mean by a return value. So it returns a value instead of its name. This value will be captured either with an assignment into another variable, and that variable we can then in the future like use it again and again instead of calling the function again with the same arguments, or we can directly, just without saving the value of the return value, we can just directly display it on the screen. So now I'm gonna like 2 to the power 3, this is 8 as we have here. So this is exactly the same thing. Now this concludes the usage of functions, and we've seen in this lecture here ready-made functions that belongs into the CMath. There are many functions you can use. For example, we can have any of the functions that we've used that are ready-made here. We can use any of these just directly by adding the CMath, and you are free to use any of them in your code, or you can write your own function. Say I can write my own POW function without looking it up in the CMath, and this is what we will do shortly. Remove this thing here, execute. See, I have an error, POW undeclared, because I just removed the include CMath library. Now say I would like to write my own POW. So I would like to write my own function that will imitate the same functionality of this POW. So it will raise x to the power of y. Raising x to the power of y is nothing but multiplying x by itself y number of times. So let me write down here. Let me, for example, for simplicity, have it as this is a float, then POW, and then since x is a float and y is a float, so it will expect two floating point variables. So float x, float y, and then open the curly brackets, close it here. Since this is since this will return a float, then at the end I have to return something here. I have to return the result as a floating point. Now I'll leave this empty for a moment, and I'll just fill it once I have the number, but I wrote return just to remind myself that never to leave it open, since this is something to be returned here. Now what we said here is I'm gonna multiply this x with itself y number of times. So think about it, pause this video and try to solve it yourself. Try to write a POW function that returns a float and accepting two arguments, each are floating point, every time multiplying this y number of times. Now I hope you tried your compiler to solve this problem. If you could not solve it, that's fine. We will solve it together now. Repeating multiplying x by itself y number of times, this reminds us of a for loop. So I'm gonna loop y number of times. So this is a for, say int I equals 0, I less than y, I plus plus. If you wrote this thing, then fine, you got halfway through. Now I'm gonna repeat y number of times. What? A result, maybe I'm gonna multiply this by itself. So it's something like this, x times x, is it? but I have to save this value into a variable, so call it R result, and this variable should be R equals, so it's a float, since everything here is float. R is result, and initialize, since this is multiplication, so I should initialize by 1 because 1 will have no effect on multiplication. If I put 0, then this is a problem. Now if I write it like this, then every time I'm assigning x times x, putting it into an R, this won't help me much, because every time I'm overwriting the old R, I would like to build up on it. So for example, if this is 2 raised to the power 3, then this is nothing but 2 times 2 times 2, 3 times. Now R should at the beginning hold maybe 2, then the second round I'll multiply whatever I have as a result, which is 2, by another 2. Now it should be 4. Now at the third time, whatever result I have, which is highlighted in blue, which is 4, multiply by 2, so I should get 8, and so on. Starting with R could be say 1, since 1 will in multiplication will not change the result if I multiply anything by 1. Now here this is wrong, so it should be replaced by R equals R times X. Now this will fix it, because at the beginning R is 1, so if this is the first iteration, means the first loop, first turn into this loop, then 1 times x, x is, if x is 2, then 1 times x, R is, so R at the beginning will be 1, and then after multiplying by 2, then R is 2, and then I just take this out, and now next time R is R times X again. Now R is 2 and X, I'm gonna take this out now. This will be 2 times 2 is 4. Now this is 4 now, and I take this out. The third time R is 4. If I multiply by X, X is 2, it never changes, then this will be 8. And this will conclude this experiment now. So this will solve the POW. If I execute, yeah, I forgot to return R. Yeah, so after calculating R, I must return it, and this is my definition of POW, and this will conclude. If I say 2 to the power 3, I get 8, and without using the C math library. So I wrote my own POW. You should be able to write your own functions using the same methodology. Now, if, say, for example, I would like to write a function that will imitate the absolute value. So, for example, if I would say cout abs absolute value of -5, it will return 5. And if I have like 5, it will remain 5. So this is a simple function. I can just write it down here. If this is an integer, then it's gonna return an integer, so it's int, then abs, then it's taking an integer as we have here between the parentheses, then it's int, say any variable a, open and close the parentheses. Now it's a single if statement. If a is less than 0, this means that it is a negative. Then I will just return minus a, else return a. That's it. That's all we have to uh, care about in the absolute value function. Now if I'm gonna execute this thing here, now we have it's waiting for x and y. Okay, 2 and 3. Now see, we have 5. It was printed because we printed, we displayed using the cout stream abs minus 5, and it gave me 5. So so this worked perfectly. If we have, like, for example, 10, this should give me 10. 2 and 3, 10. So we have here two examples of functions that have been written, one with 2 arguments, the other one with 1 argument, and both having a return value. So we have return value. This one here is returning a floating point, and the ABS is returning an integer. If you notice, every time I write a function, I write it before the main, just after the include, and this thing a bit annoying because it will keep pushing the main all the way down, and it will cause problems if I have like many functions. Then if my code like is big to fill like 20 pages, then I have to look for the main part, because usually we understand programs by looking at the main function to see how pieces and parts of the program fits together. And this is why usually we would like to have main at the beginning. So it's not as simple as just grabbing this function and just putting it below. Okay, let's do it like this. Control X, let's put this here, Control B. Now I have them both under, both of them are under the main. Now POW it's complaining. See, it's complaining now, POW undeclared. Even if it's declared after the main, but it needs to be declared before the main. And if we put it before the main, it will keep pushing the main all the way down, and we won't have the clear vision of the program. So I have to like scan through the code till I see the main. So programmers usually like to have the main at the beginning. So this is why we come to what we call a prototype. A prototype is nothing but copying the header of the function, Control C to copy, and then Control V just to paste it here, and then with a semicolon. Then this will give an indication, okay, POW is a known function that will be declared later on, but this will give an indication in the main that when it goes over POW, okay, this fellow is already here. So this is a prototype, as if just to give indication it is defined later. We can do the same thing here with ABS. Just put a prototype for each and every function that you are, oh sorry, I don't need all this. I just remove and put a semicolon. Now if I execute, it will run 1 and 7. Fine, so it's working. So this is all about prototype. Actually, in prototype, all you care is to give the return value, name of the function, and number of arguments and their type. So we have two arguments here of type float. The name here has no meaning, so even if I remove it, because there's no body to connect with, so even if I move them, so this will only give indication that POW is a function, returns a float, has two arguments, both of them are float. ABS is a function, returns an integer and takes one integer. This is all I need to know about a prototype, and every prototype should end with a semicolon. So if I execute, see it's working now. It's the same. But when I declare the function, I have to have the variable names. Actually, these variable names need not be exactly the same as the variable I'm calling, because it will be substituted. Now x will the first argument, placeholder, will substitute in this first argument here. So this will copy the same value. Even if I change it here and have it like a and b, then every x here should be a and every y should be a b, and this should execute correctly. So my famous example is 2 and 3 will give me an 8. So see, x equals 2 and y equals 3. It has been written correctly, and the r is 8 has been calculated from the POW function, even though it's an a and b. Hence these values are substituted by whatever is in the first and second argument here. The same thing can be said with as we have here, 10 will be substituted in place of a, so every a here will be a 10. This is why we have if we have -5, it will be negative of -5. This is +5. So this is all what to say about the prototype function with more than one argument. This is a function with one argument. Now, an example of a function that does not return any argument is if you would like, say, for example, to have a function that will print or display its output without having it like returning a value. Say, for example, if you would like to have a POW as a void. So if this is void, then you no longer can use it like this. So since it is void, there is no return value, so you cannot capture R, and all this will have no sense to exist. So you enter x, you enter y, and then POW x to the power y, and POW will take care of displaying the value. This is why it's void, so it's not returning anything. Hence this should be also void, and instead of return you just see out the value r. Now if I execute this thing here and I put 2 to the power 3, now 8 has been printed inside the POW. See, it has been printed. Instead of returning a value, it has been printed. So there is no sense to say r equals POW, because it's not gonna return any value. This is where we have a void. Void means it will not return a value. It will consume these two arguments, make some operation using them, and then just either display or just return nothing. So displaying on the screen doesn't mean a return value. A return value means you have to have a return, and the value will be posted back and handed to the main function. You can grab it either with a variable or directly just print it on the screen, or whatever you want. This is in case if you have a return value. One ready-made function that return a value with no arguments. Sometimes you may have a function with no arguments. You may have a function with no arguments. Say, for example, if you have void like welcome. This is no arguments here, and then I just define a welcome function, welcome, and then just it displays something on the screen. Welcome to my program /n, and then just close it here. Now before I ask the user to input X and Y, maybe I should say welcome. That's it. Execute. Now welcome to my program, 2 to the power 3, I have 8. If I say welcome again, then I have 2 welcome messages as I have here, and then 2.3 to the power 3, I have it like this. So this is an example of a function that do not have a return value and do not have a parameter passed, and this is an example of a function that have one return value, an integer, and one argument. This is a function that has 2 arguments and 1 return value. Actually, functions can only have 1 return value. If you would like to have to return 2 variables, 2 things to be returned, for example, if you would like to find out the minimum and the maximum of say 2 numbers, then this what we will see in our next lecture. Having more than 1 value to be returned, it will be returned by having some parameters being changed in the argument itself. So we pass them by reference instead of by value. We will see them in the next lecture, but for now this is to finalize our lecture today. So we repeat it fast here, just to summarize everything here. We've seen in this lecture how we can write functions having a return value or no return values, 1 argument or no arguments, 2 arguments, and we've seen how we can write a prototype, what a prototype means, why we need a prototype. A prototype, as we said, it will make our code looks better, just to make main always next or very near to the starting point of the file. And we've seen how we can use ready-made functions by including the cmath. We have other very interesting functions, such as the random number function. A random number, as so for example, if I say cout rand, so rand will generate, so this is a ready-made function, this is already included in the IO stream. This will return a number between 0 and something like 32,000. Every time I call it, it will return a random number. So I got here 41. Let me clean up everything here. This is after welcome, POW. Let me remove these 2 here. Now, every time I execute, it gives me the same random sequence. So I got 41. If I cout again rand, it will give me the second number in the sequence. So second number what was 1846. I can have it like this. If I just repeat it again, you cannot predict what number it will get unless you've run it before. So it's now 6,334. So there is no sequence that you can based on this you can predict what's the next number I'm gonna get. So this is why it is sort of random, but it's every time it's repeating the same random sequence. Next lecture we'll see how to overcome this repeated sequence with having a seed number and seed it with a different number every time it gives us a different random sequence. So we'll see more about this random function with more interesting applications in the next lecture. I hope this was useful, and see you in next video.